Hi, for today's lesson, we'll be talking about interpreting graphs of changing quantities. With graphs, we can either have graphs that are linear or nonlinear. Linear graphs have a constant difference between their term, which causes a linear pattern. We get a straight line graph. So, an example of this would just be ordinarily y is equals to mx plus c line. Now, we also have nonlinear graphs. They do not have a constant difference, and the rate of change changes, meaning the way the y changes with the x changes between the terms. This will cause the graph to have a curve or a change in direction. An example of this would be a quadratic equation with either a smiley face or a sad face. Graphs can either be constant, increasing, or decreasing. When a graph is constant, one of the y variables remains unchanged while the x variable changes. It could also be the other way around, where the x-axis or the x-axis variable changes and the y variable remains the same, and in this way we will get a graph that is parallel to the x-axis. So if we have a y that is unchanging, our line will go like this, and if we have an x that is unchanging, our line will be parallel to the y-axis. We can have an increasing function when the relationship between the x and the y are in direct proportion. As the x value increases, the y value also increases. So with our straight line, we will have something like this, and with our curves, we would have something like this. So in this case, the y values are increasing with an increase in our x values, or we can have this. In this case, our y values are also increasing with an increase in our x values. The difference between this and that is the rate of change. The rate of change for this graph is positive, meaning the relationship that x and y has increases with a point, right? Maybe at this point, when x increased by 1, the y would increase by 2. But at this point, when the y increases by 1, the graph increases by 2. Whereas here, the change in y is negative. Right? Meaning at first, we would be changing at a difference of, for each point, we will add 6. But as you continue with the graph, you go to another point in your x direction, it's now changing at 4. It's only increasing by 4 points, so it's somewhere 10. Here it increased by 6, here now it's increasing by 4. The next thing we know, it is increasing only just by 2. So the rate at which y is increasing is decreasing here, and over here, the rate at which y is increasing is also increasing. We have a decreasing function where the relationship between the x and the y are in direct proportion or inversely proportion. This means that when the x value increases, the y value will decrease. For a straight line, we'll get something as simple as that. And for a curve, we can get this, or we can get that. So we can clearly see that our x values are increasing in that direction, but our y values are decreasing. Even here, we see x as we go towards the right is increasing, but our y values are decreasing. Let's talk about the rate at which they're decreasing. The rate at which this is decreasing is negative, but it actually means it's increasing with time because it's in the same sign as what is happening to your graph. It's decreasing. So the rate at which your gradient is changing is decreasing. So as you go down, the changes become bigger and bigger. Unlike this one here, where the rate at which your gradient is changing is increasing with time. So the lower you go, the higher the changes are between your y values from your previous values, the change in between. Let's take a look at some examples. This example says, which graph in example 3 could show a car sitting at a spotlight, this one or that one? So if something is not changing, your distance is not changing, we should have what? A constant graph, meaning that our y value should sit at a constant number, and therefore this graph will represent someone who has stopped at a stoplight. Let's interpret this graph that we have here of temperature against time. We will see that in the beginning, our temperature was increasing with an increase in time. And after some while, our temperature remained constant. And here we can see that the temperature has decreased. One last example. Here says water is being poured steadily into the vessel or into the vessel. Draw a graph that shows the relationship between height and the volume that has been poured. Okay? So the volume is given by area multiplied by height. We can clearly see here that height is directly proportional to the volume. Right. So for the first graph, what we need to understand is that for our equation here, the first part of the graph, we have a much larger area. Therefore, we would require less height for the same amount of volume. Whereas for the green part over here, we have a much lower cross-sectional area, so we would require more volume or more height for the same volume. So we can see here that for the same, so let's say that we're increasing the volume and we're increasing the volume just by 1 meter cube, 1 meter cube, 1 meter cubed, right? We will notice that this part is constant, but the height then is less for the same amount of volume because the cross-sectional area is more. And for the second part, for the same amount of volume, we would then have a much higher volume because why? We have a much smaller cross-sectional area. So we're expecting a little bit of a steep rise. So we're expecting a gentle rise here and a steep rise over there. Let's look at B. The first part of B, the cross-sectional area is increasing with an increase in our height. Okay, so the volume, we want to pour the same amount of volume, and here our area is continuously changing. So in order to meet the same amount of volume, the height must change. So when this decreases, this is going to increase with time. Right. And that is why we see a curve that is increasing, but the rate at which it's increasing, is also increasing. So at first, we would cover a height of, let's say, just 1 meter, but with the same amount of volume, then we would cover 2 meters instead of 1. Then for the same amount of volume, we would cover 3 meters instead of 2. So the volume at which the height is increasing is also increasing. Good. And then we get to a part where we have constant cross-sectional area. So there is going to be a constant change in height. So you get sort of a straight line there. Right. Not even sort of a straight line, but a straight line. Then let's look at C. C, at the bottom, we had a small cross-sectional area. So to keep the volume the same, we would need to change our height. But as we go up, what do we see about the cross-sectional area? It is increasing. So initially it was small and it is now increasing. What should happen to the height? The height should decrease, right? Obviously, the height of the volume is increasing, but the rate at which it's increasing is decreasing. So, for example, we started off filling up, so the same amount of volume filled up 1, and then the same amount of volume now is going to fill up 0.5, so must be less than. And then the same amount of volume would now be filling up 0.25 in that direction only, you understand? So the height difference is what I'm talking about when I say 0.4, but your height is increasing, right? Even though it's increasing by 0.5 and then increasing by 0.25, but it is increasing, but the rate at which it's increasing is decreasing until you get to a point, which is here. You will see that your cross-sectional area now is decreasing. So what should happen? This should increase at an increasing rate. So now you'll find the difference between the 2 points with regards to height is increasing. You used to do 1, the difference that is. Then now you're doing a difference of 2. Then you're doing a difference of 3 until you get to this point where it's constant. So you should have ended up with a straight line. Last one here, we have very large at the top, the bottom, the cross-sectional area is increasing, so what the volume, the rate at which the volume is increasing must decrease. So we have this. This theme is continuing, so we have those 3. It's just that each and every time the height there gets a little bit smaller and smaller.